Hello. Oh. Hello, hello. Testing 1, 2, 3. Let's publish to. Let's share to Twitter. Let's share to LinkedIn. I wonder if this actually matters. I don't know. I hope so. Okay. So in the last session, we finished with installing Section 5 developer environment, basic installation of Python on my local computer. That's done. Oh, wait. Wait. So local installation of Python, that's already done. What we are going to be doing today is going to be Section 6. Learning. Let's keep working on Section 6. Wait, what? No. Wrong course. There we go. This past weekend.
Hello, I'm super excited to start this course with you.
Start? No, my friend. Okay, there we go. Okay, so anyway. Let me fixing some stuff anyway. Okay. So today we're going to continue with the complete Python developer course. We are going to be working on Section 7. So let's see what do we have for Section 7. Oh no, I lied. I just finished Section 5. I am starting Section 6. Section 7 is not what's next. Okay, Section 6 is Advanced Python Object-Oriented Programming. Yeah, get to it.
Such an important topic for us to become great developers. Now, when I say everything in Python is an object, what do I mean by this? Well, remember our data types that we've talked about? If I click run here, you'll see that we have all our data types, but we have this class keyword in front of it. And I mentioned previously that this is something that we're going to get into. Now, everything here is an object because in Python, everything is built by this class keyword. And we're able to use different methods on our objects like this to perform some actions on them. So what is an object? Objects have methods like these and attributes that you can access with the dot method. Now, object-oriented programming allows us to go beyond what Python just gives us, which are these data types. But wouldn't it be amazing if we can create our own and make Python even more powerful? And using object-oriented programming, and what we're going to learn, the class keyword, we're going to be able to do just that, so that the list over here can grow to our own custom objects. Now we're going to explore this topic of object-oriented programming, what objects exactly are, and what this class keyword is over the next couple of videos. But the key takeaway is that we're able to create our own types, our own data types, with different attributes and methods. Now, why is this useful? Let's have a look at an example. Let's say we're working for Amazon. And Amazon recently decides that, hey, you know what? We're going to have delivery drones that are going to deliver our customers' packages a lot faster. But we need to code this drone, right? And up to this point, we've learned that we can do that with basic functions, conditional logic, and just writing our code on a .py file. But the problem is, as code gets bigger and bigger and bigger, it's not just one file. It's not just 10 lines of code. It becomes hundreds and thousands and millions of lines of code divided into different files. Code gets more and more complicated because we live in a world where technology is everywhere. And programming something like a drone is quite complicated, especially when it's a delivery drone. Mm-hmm. So how can we use object-oriented programming to make this code more manageable? Well, OOP is what we call a paradigm. That is, it's a way for us to think about our code and structure our code in a way that is easier to maintain, extend, and write. So if we're writing a program about, let's say, that does drone delivery, well, we break it up into small pieces, into little objects that represents the real world. For example, I might code an object, my own data type, which is the propellers that allow the drone to fly. And maybe another developer works on the camera and the vision part of the drone. Another developer can perhaps create the claws that hold the package. And then another developer might be able to work on the signaling so that we're able to send signals from our drone to, let's say, Amazon headquarters and know where all our drones are. What we're doing here is we're breaking up functionality and data into different pieces that model the real world, into separate objects, so that different people can work on different parts and then we can just combine them after.
Yeah.
And the beauty is when we want to, let's say, create a delivery system that's not a drone this time, well, it's a tank-like delivery robot. We can use the same pieces, such as the camera and the claw and maybe the signaling, but we can just remove, instead of the propellers, and use the tracks that, let's say, tanks use. And somebody else can code this part. But we're able to use different pieces, extend functionality from our drone into different objects. Now, if you still don't understand 100%, don't worry. We're going to go over this over and over throughout the next couple of videos. The main takeaway is that OOP is a paradigm, a way to think about our code, a way for us to structure our code so that as it gets bigger and bigger, we're able to be organized. Because we're not writing silly 10-line codes. We're writing millions in lines of codes. Companies like Netflix have thousands of developers that are writing code every single day. They need a way to structure and organize this code so that, well, it just doesn't turn into complete chaos and complete spaghetti code. Let's take a break and learn more about OOP in the next video.
Okay, I'm going to replay that one for you. I need to go to the restroom, but I'm going to be back really quick. And
in the next couple of videos, we're going to talk about this idea of OOP, or object-oriented programming, what it is, what it's useful for, and why it's such an important topic for us to become great developers. Now, when I say everything in Python is an object, what do I mean by this? Well, remember our data types that we've talked about? If I click run here, you'll see that we have all our data types, but we have this class keyword in front of it. And I mentioned previously that this is something that we're going to get into. Now, everything here is an object because in Python, everything is built by this class keyword. And we're able to use different methods on our objects like this to perform some actions on them. So what is an object? Objects have methods like these and attributes that you can access with the dot method. Now, object-oriented programming allows us to go beyond what Python just gives us, which are these data types. But wouldn't it be amazing if we can create our own and make Python even more powerful? And using object-oriented programming and what we're going to learn, the class keyword, we're going to be able to do just that, so that the list over here can grow to our own custom objects. Now we're going to explore this topic of object-oriented programming, what objects exactly are, and what this class keyword is over the next couple of videos. But the key takeaway is that we're able to create our own types, our own data types, with different attributes and methods. Now, why is this useful? Let's have a look at an example. Let's say we're working for Amazon. And Amazon recently decides that, hey, you know what? We're going to have delivery drones that are going to deliver our customers' packages a lot faster. But we need to code this drone, right? And up to this point, we've learned that we can do that with basic functions, conditional logic, and just writing our code on a .py file. But the problem is, as code gets bigger and bigger and bigger, it's not just one file. It's not just 10 lines of code. It becomes hundreds and thousands and millions of lines of code divided into different files. Code gets more and more. You see, we started with basic programming languages. We had things like assembly language that was really low level, really close to machine code. We had things like COBOL. And then we slowly, as we started writing more and more code in the 60s and 70s, we started establishing some of these fundamental paradigms. And one of the big paradigms that came to be, especially with the Smalltalk programming language, was this idea of object-oriented programming, or an object-oriented language. You see, up until that point, we wrote what we call procedural code. What that means is that if we look at a Python file, for example, a procedural code was just like a procedure. We simply had lines 1 through, let's say, 100, and we just went from the top of the line to the bottom of the line. We had conditionals, maybe loops, but everything was do this, do that. It was us telling the machine, hey, just do exactly this what I'm about to tell you. With the introduction of object-oriented paradigms, this changed a bit. We started saying, hey, let's model something in our code that represents a real-world object. For example, if I'm about to code a car, I would create a car object that has data on what color it is, what type of engine it has, how many seats it has, but also actions like methods that we can take on it, such as the car can go forward, it can go backward, it can open the door. And instead of having these line-by-line procedural code, we can think in terms of models, real-world blueprints. Because as humans, we organize things. Think of a room, think of a factory. By organizing things and having different groups in a specific location working together, that's a better way to think as well as to run things. So how would this look in Python? Well, Python is an object-oriented language, or can be, which means that it's able to support OOP ideas, this idea of objects and modeling. And we've seen this when we use the type. We see that everything is an object because we use this class keyword. But what is this class keyword? In Python, I can create my own data type, my own class, by simply saying class. And then afterwards, I can name it whatever I want. Let's say class big object. Now, right away, you see here that the naming convention is different than what we've seen before. We're going to make sure that it's capitalized, which is the standard. We want to let programmers know that this is going to be a class. And we're not using the snake case, we're using what we call camel case, which is every new word is a capital letter. And then here, we use the colon, and then in here, we write our code. Now, I'm not going to write the code right now. I'm just going to pass. Right there, I've just created a new class. So that if I do, let's say, for example, type big object, and I click run, well, I still get type. Because right now, what we've created is this class, which is a blueprint, but we haven't actually created the object. I know the wording can get confusing, but bear with me. I will explain this. We can now create, let's say, object1 equals to big object, and then run this class. So that if I do type object here, object1, and I click run, I get class big object. You can ignore the main here for now because we're going to talk about it later. But you see here that I've just created my own object. Okay. Now, let's think about what just happened here because it is a lot to understand. You see, in object-oriented programming, there's this idea of a class and an object. Now, a class is this. It's the blueprint of what we want to create. What are the basic attributes, that is properties, that our class has? What are some basic methods or actions that our class can take? And then from this blueprint, I'm able to create different objects over and over using this as the building block. So this blueprint is what we call a class, which we define with the class keyword. And this class can be instantiated, that is the action, of creating different instances. And what are these instances? These are all objects. Now, the naming here is something that you're going to have to get used to, and all object-oriented programming languages have this language. So you'll just have to understand when somebody says, hey, I just instantiated a class. It means, hey, I just created a new instance, a new object. So looking at this diagram, let's go back to the code that we just wrote. We've created here a class.
Yeah, here the main idea of object-oriented programming is, well, it is right. One of the analogies I like to use in this case is, imagine that a class is are the blueprints for a house, for example. So the blueprints for a house are not the actual house. But let's assume that you are going to build this house that is designed inside the blueprint. So you use the blueprint to create one house, but it doesn't mean that you cannot create many other houses with the same blueprint. So in this case, you can actually create instances which are going to be the houses themselves, and you are going to use the class as the blueprint to build this house. So basically, you may build 1, 2, 3, 4 houses, and although they come from the same blueprint, we are later going to see what attributes are and methods are and inheritance and all of that. And basically, this allows you to have enough flexibility to, let's say, okay, so maybe this house is going to be have this specifically, but maybe for geographic location specifications or something like that, maybe you are going to make a little modification to one of the houses because maybe it's on a ledge, or maybe it's next to a wall, or maybe is next to a hole or something like that. Or maybe you just need to move the class specification or the blueprint. You need to change the blueprint a little bit. Or you don't need to change the blueprint a little bit. You just need to change the house itself. Maybe you need to move the wall a few inches away from something. And that's the idea of attributes and whatnot.
Back to the code that we just wrote. We've created here a class or a blueprint. And then here, this double bracket is us instantiating the class and saying, hey, class, use whatever you have code in here and instantiate it and create a new object. So we're creating a new object by instantiating.
So basically, the idea here is in line 3, you create the blueprint. On line 6, you create a house.
This class. And this is exactly what we're doing with something like a list, right? I can create multiple lists over and over and over. And every time I create a list, I have access to all of these methods and sometimes even attributes that I can use. And this way, I save a lot of time instead of coding it myself. And in the same way, I can create multiple objects here. Object 2, object 3, just like that. And now I have 3 different objects that I can use.
These are the 3 different houses that you can build by just using the same blueprint.
Based on this blueprint. Now, the blueprint right now doesn't have anything because, well, I can add code here later, and we're going to do that in the next video. But the beauty is, let's think about efficiency here. You see, the blueprint itself, the class, is going to be stored in memory. So Python interpreter is going to say, hey, big object is going to be the blueprint for this. So I'm going to store all that code in memory. But every time I create an object, I don't have to rewrite the code or do anything like that. I can simply say, hey, go in memory to where big object is and just run that code. So that, again, we're keeping our code dry. We have one place that allows us to instantiate our code into objects. Let's take a break and expand on this class in the next video.
Creating our own objects. Okay.
Now, the best way to learn is to actually see code in action. So enough theory, let's actually code our own class. I'm going to just delete everything and start from scratch. And let's say that we're working for a gaming company, and this gaming company has, well, this wizard game that they want to create, almost like Harry Potter. Now, how can we think about it in object-oriented programming? Well, the first thing that we're going to need is we're going to have players, right? Each player has a character that they need to play. So let's create a class here. And
well, really, when you are actually working, there is planning beforehand. A little bit of planning. You just don't do this. You don't just sit there and type up away and create classes for everything that has a name on your game or your software. What most commonly happens is that you sit down, maybe in front of a notebook and some pens, and you begin making sketches of how your design is going to come about. You don't really sit down and just begin typing, but experienced programmers can actually skip parts of that process because they already know, well, this part over here, I have already seen this this play out before, so I don't really need to design it again.
Like player, character. Again, notice the naming convention because it's a class. And another rule is that usually you want it to be singular, not plural. So you can't say player characters because, I mean, it's a blueprint. From this blueprint, we're going to create many characters, but those are going to be objects. So player character, single.
Yeah,
in
that's
here, I'm going to do a few things. And I'm going to warn you, this is going to look confusing at first, but bear with me. I will explain. We're going to define a underscore.
Yeah, I guess this is where most people is going to drop from the course, even though most people are already they have invested a lot at this point. But I can see clearly that this is where where the meat is going to, how do you guys say, when the meat fell off from the shaft, something like that. I don't know.
Or underscore in it, underscore underscore. Now in here, we're going to say self, and then give it a name, the name of the character. From here, we're going to do colon once again, and simply say self.name equals to name. Oh boy.
Oh.
Again, I'm going to hold off explaining what this does and just write a few more lines of code so that it makes a little bit more sense. I'm going to write another method in here, and I'm going to define, let's say, a run method that each player can run. And in here, I'm going to once again have this weird self word, and then simply inside of here, say print run. All right, so I've just created this class. It's still kind of confusing. We don't really know what this init is, what the self is, and this whole new look. But let's ignore that for a second and simply say player 1 is going to equal player character and instantiate that player so that we can print player and see what's up with this player. If I click run.
Nothing, because you need to initialize it.
It says init, missing one required positional argument, name.
It requires.
Right, let's take a break here and see what is happening here. You see, this init method is a special method. You see the two underlines here? This is called a dunder method or a magic method, and we're going to have a video specifically about this. But when we're building a class, you usually see this at the top. And this is what's often called a constructor method or an
constructor.
And this is automatically called anytime we instantiate. Remember, instantiate means is we're calling the class to create an object. So when I do this, it's going to automatically run whatever is in this code block. So when I run this, you see that I'm getting the error on line 9 right here. On line 9, when I try to instantiate the player character, it runs init, and then it tries to do self.name equals to name. But the problem is that I'm not giving it an argument name. And that's because when we call init, we accept whatever is after self as the parameter name. So we need to give it a name of this character. So let's say the name is Cindy. If I click run here, all right, it looks like I have a player character. And as a matter of fact, it even shows me that it's an object at this memory location. So on our computers, this is where
it's not printing the value, but
very cool.
Yeah.
What is this self keyword? And what is this code on line 4? This is a way for us to define, well, self. Self refers to the player character. It's saying, hey, this is going to refer to this player character that we're going to create, player 1, and I want self.name to equal whatever the parameter name is. So that if I do player.name here and I click run, I get Cindy. And why is it Cindy? Well, because I gave it the parameter, player character, and when I instantiated it, I passed the name parameter. The default parameter is self when I do init.
¿Qué pasó? ¿Por qué? ¿Qué pasó?
Es que no hay tortilla y mamá va a comer.
Ah, a ver. No, ahorita voy. I got to go, but I'll be right back. Never mind. Actually, I can set up a be right back scene. There we go. Well, looks like I'm back again, I guess. Okay. Hello again. Can you hear me? Okay.
And in classes, you see here that the default, always the first parameter when we're defining a method is self. And now I give name to self.name. What if I remove this here and I click run? you see that it says object has no attribute name. Because in order for me to say, hey, I want player to have
I need to make a
I need to say
reference.
self dot, because self refers to player 1. So if you remember, when we had a list, we had to do dot, and then we would say append. Well, somebody wrote this append code, and in the append code, it's going to say self dot, let's say, add to the list. And self refers to whatever's to the left of the dot. So this way, it allows us to have a reference to something that hasn't been created yet. In this case, player 1, and let them know that, hey, when it's created, when we instantiate, then I want you to make sure that player 1 has this name attribute. So that if I create another player, and player Tom is going to be player 2, if I print player2.name, and I click run, I have 2 different players with 2 different names. I was able to use the same piece of code, but have different values, because the self, every time I instantiate this, refers to first time player 1, then second time player 2. Now, self is one of those things that gets really, really tricky to understand, and you might need to watch this video a couple of times. But the key here should be evident to you. That is, I'm able to write code only once. Remember our principle, dry, do not repeat yourself. And I'm able to make it dynamic by saying this data that we're going to create for the object is going to be dynamic, and it's going to change based on what we give it. So that I can create different players with different attributes, but still use the same code. Now, I can have multiple things here. I can have age, for example, and once again, I can say self.age equals age. And then Cindy will have to pass, let's say 44, and Thomas.
But that's required.
So that here, once again, if I do age, they'll have different attributes. So remember, these are attributes or properties that these objects have. And you can access them by doing the dot notation and then accessing the property itself. You see that I don't have any brackets here because it's not a method. It's not taking action. It's simply saying, hey, I want to access this attribute. If I do dot here, my editor will actually tell me and will have the symbol for, hey, you have access to the attribute age and name. And as a matter of fact, I also have access to run the method. So that if I click run, well, remember, a run is a method.
It's
so I
a
get
method.
this
Yeah.
method, but it's not printing anything. It's not taking the action. So we have to, once again, add the brackets, hit run, and look at that. I'm able to do run, then I get none, then 21. Why do we get this none? Because remember,
Which is a little bit weird because the method run is already print and run. And he's calling that from another nested inside a print statement. So that's a little weird for my liking, but I get it.
remember, this is a function that doesn't return anything. When a function doesn't return anything, what do we get? We get none. So maybe I can just say return done. If I click run, there you go. We have run, done, 21. Now, one last thing before I end this video. The interesting thing here is if I do player 1 and then player 2, and I print this, and I click run,
Yeah, there are 2
you'll
different
see that I get the
addresses.
player character, but the object, each of these objects, player 1 and player 2,
they
are
belong to different
memory locations.
memory locations.
So I'm able to use one piece of code, one blueprint, to create multiple players. But these players are not the same. They're created from the same blueprint, but they live in different places in memory. And that makes sense, right? We don't want Tom and Cindy to be the same player. They're 2 different players. So this way, we're able to keep things safe. And anything I add to player 2, for example, let's say player 2 can now attack, and attack will just be a property that will be 50. Now, if I do dot attack here, you see that player 2 has attack, but if I do player 1 dot attack, I'll get an error.
Okay.
Object has no attribute attack. I hope
Yeah,
you
it
start to see the
doesn't
power
have
of
it.
classes. Although it may be difficult to understand at first, the power becomes evident when we are able to create this blueprint that we can now use over and over and over to create our own objects. Let's explore more in the next video.
Okay, before continuing with this one, I might like to make some experiments here. Let's remember that my background with object-oriented programming began with Java. So what's this? Oh, wait, this is another thing I've been working on. Close folder. Where is it? There we go. Okay. Okay, I guess this is an exercise. I may like to create at least, I wonder if I can name it something related to the section. Section 6, Advanced in Python, section 6, I'm going to Advanced Python Object-Oriented Programming. Okay. Section 6, OOP. And inside, well, this is not really, but I'm going to create another one called miscellaneous. And I'm going to put this one here. Yeah, move it. Thank you. Okay. Let's make a formal. Let's make a formal commit for this. There we go. Okay, and now inside the section 6 OOP folder, let's create a class sample.py. Okay, so what we're going to do here, It's something very simple in my opinion. I'm going to create a class. I'm going to assign it a couple of attributes and try to play around with them and see what can I do. Let's see, def, I don't know. Oh no, it's not def, it's actually class. There we go, class. Let's say, oh, I don't know, house. Oh wait, no, this is not Java. Can I do this? Okay, that's valid actually. What's going on? It doesn't conform to Pascal case naming. I guess he's telling me this then. Just like in Java, I need to name my classes appropriately. Oh, missing dog string. Yeah, why not? Let's comply. Why not? I'm going to actually put this. It's a simple class. There we go. Yeah, nothing too fancy. It's just an example. What else do we have? Wait, is that extra space comes from the linter? Yes. Okay. What else do you need? Missing class. Oh wait, this needs to be inside. Okay, I get it. Like this, maybe. Okay, no indentation. Like this. There we go. Okay, pass. What happens here? Unnecessary pass statement. Okay, I guess I can. Well, yes, it's unnecessary indeed. Okay, so let's try to create the constructor first. What is in it? Like this. And I'm going to set self. Wait, why is with self? It's not an attribute like that. Okay, let's see. Self is oh wait, it's a def. I need to define a method first. Def. There we go. Okay, it's not complaining anymore. Just oh wait, here I'm going to be listing my. Okay, it is time to begin listing the attributes. Okay, so first, typing extensions. Oh no, don't need this. Okay. Okay, let's try. Okay. Well, let's see. Self dot name equals name. But I guess I need to add name as an attribute. And def, I don't know, get name. Yeah, I know this is an anti pattern, but this is just an example. Let's try to return self. Oh wait, I don't have self here. Self dot name. No. There we go. So I had my class here. I only have one attribute here and one method that returns the get name. There is something blue here. What's the issue? Method name get name doesn't conform to snake case naming. Okay, so do I need to say like this maybe? A snake case maybe like this. Is this okay? Get name self Oh, I'm missing the return value. Missing function or method. Dog string. Pilot. Missing function dog string. So I'm going to need another here. What's the name of the house? Oh, maybe player. Why not? Let's modify to player. Why not? There we go. Self name. Okay, and just have a very basic class over here. Is that a problem? Too few public methods. What do you mean? Missing model dog string. So I need model. Oh, you mean the entire thing over here? So this thing over here. Okay, I don't think it's complaining anymore about anything. I guess I'm going to replace all this. Like this, maybe. And I have a couple of methods. And that's pretty much it. It doesn't do anything else. Okay. I can give it more, I don't know, health underscore points equals to 10. And I don't know, maybe ammunition self dot or ammo equals to 30, something like that. I guess I can self dot is alive equals to true. So some attributes that I can come up really quickly here. And I can just say, you know what, get the name. It just returns the name. That's it. Nothing fancy. Let's see. Okay, the linter is not complaining about anything. So let's continue here. What else can I do? Wait. Let me see if I can reset the zoom. There we go. So I may have more space for the actual text for the code. Okay. So I have a class over here, but I'm not using it for anything. So what I may like to do now, is, well, use this class for something. So I'm going to create let's say, who knows, a variable called player1. You're going to be equals, and what was he using here? The name of the class in camel case, and sending attributes. Okay, so player camel case, and I'm going to require a name. So I'm going to call it Cindy, something like that. Okay, and right next to it, I'm going to player1 dot I can use attributes. So the attributes are not private at this point. So I can just say get name and print this out. I might just print the name. Okay, let's go to the terminal. Okay, so Python 3. There we go. It reads bound method player get name of. It's not returning shit. Why not? Oh wait, I'm not calling it. I am getting the actual function. that's why it didn't fail. It's printing the memory access, which means that I can download or get the actual function itself. That's interesting. Because I can do that in JavaScript. I wonder if I can do the same here. But anyway, that's not what I want to do. Let's add this couple of parentheses in order to actually execute the function over here. And now let's try again. And there we go. I'm printing Cindy. Okay, so I wonder if I can print the name directly without this method here. Name. It looks like I can actually. Let's try again. And there we go. I can print directly using the method that I use, or how do you call it? Or basically just addressing the attributes themselves. I wonder, how do you define attributes for private and protected and whatnot? You know, security. In this case, I may like to replace this for something like how do you call it? Get damage or get hit. Why not? Get hit. And I'm going to use self. And instead of returning something, I'm just going to say, you know what? Self help points minus equals and let's say damage. I guess I'm going to require now the damage argument or parameter here. This is the parameter. I don't have an argument yet. I wonder if I can save this. I wonder if I can run. Okay, it's working perfectly. Now, let's see if I can, what can I do here? Well, how do you concatenate here? With plus HP and player one dot help points. Okay, let's try again. No, not end. Oh wait, yeah, help points is. I wonder if there is a method for the integer as a string, maybe. As a string. Nah, forget about it. I don't think so. Okay, so but there is a function str, and I'm going to cast this object as a string, and now I can just print out. Okay, now I do have Cindy with 10 HP. I'm going to try to make some damage here. So player one dot get hit, and I need to send as an attribute any damage, which needs to be integer. I wonder why does it say any. Let's try with 3. And then print the same information again. Let's do that. Okay, so the first time Cindy comes out with 10 HP, then Cindy gets hit by 3. Now she's on 7, and so called. I guess we can make another object here called player 2. And let's say this guy is going to be John. This guy is going to be John. And let's print out Cindy and John. So player 2, no, it's going to be player 2 now. And the HP for player 2. Okay. And repeat the process afterwards. Print the names and the HP of the players. Okay, so let's see. Let's try to run this again. And I have now Cindy with 10 and John with 10. Cindy loses 3. John keeps 10. Okay. So here, I guess I can keep playing around with these values. And let's say player 2 gets 1 HP. So the next time, instead of 10, John has 9. Okay, so far so good. Things that I wonder how to do is, how do I set these attributes as private or protected? Which means that I don't really want other programmers or myself to be able to modify these values from outside the methods, basically. This comes in the. This is nothing weird. This comes from the realm of object-oriented programming. And what I want to do is, okay, if I already have this method to access the values of the HP and whatnot, then what happens if I do this? Player 2 dot. Oh wait. Player 2 dot health points equals to 100. So what happens then? Which this means that I can just assign whatever HP I want from outside the class. Okay, and I had no control over it. So everybody can just assign whatever, how many health points they want. It is supposed to be managed by the player class. But if I allow all my attributes to be public, I can basically do this like this. There we go. So it doesn't matter that I got hit. I can basically modify John's HP from outside the class, and that's not optimal. But anyway, I guess, is there something else I'm missing here? Return done. Okay, no, yeah, I guess. He's returning something here. Oh, that's fine. Okay, so let's add this. Copy relative path. There we go. I should probably do another branch for sections. I'm going to do that. Yeah, let's do it right now. Okay, how do I wonder if I can create a branch over here. I just wonder. I don't know. What's this? Views a tree. Views source control repository. Nah. Oh wait. Show git output, commit, branches. Create a branch. So you are going to be called section 6. Is this the section 6? Yeah, that's okay. Okay, section 6. Wow, I am on a new branch. Perfect. It's fine. And I have my main branch, so everything is fine. Okay, so let's continue with the course.
Object-oriented programming allows us to create objects that have their own methods, like run, and attributes, properties. It's a great way to add more functionality to a language and mimic the real world. For example, we use the idea of working for a gaming company. Although Python only gave us a few data types, I was able to create a player character. And now my boss is happy because this player character can be used all over the game. And all other coders have to do is run this line with the custom name and age of the character. So OOP allows us to write code that is repeatable, well organized, and also memory efficient, right? Because we only write this once. So if you want to be a great developer, OOP is something that you need to know and you need to understand because, well, this is how you want to organize your code. Thinking less procedural and thinking more in terms of functionality. Grouping data, like attributes, together with methods to create this class that is able to mimic something from the real world. Now I want to show you a useful tool here. We saw that when I do player dot, my editor shows me what I have available, the properties, as well as these purple boxes, which are the methods that I have available. And right off the bat, you see that I have age, name, and run, but then I have all these other ones that I got by default. Now, these are all dunder or magic methods, which we're going to get into. But the key here is that if I do something like help, which is a new function that you may have not seen before, and let's comment this out. If I click run, I actually get, well, the entire blueprint of the object. If I do something like a list, and I click run, again, it shows the blueprint that it has. And this is a great way to see what class blueprint some of the Python data types have. Now, this is something we'll revisit later, but I want to go back to this player character. Now, in here, we saw that we're able to create attributes, and attributes are pieces of data that are dynamic. That is, when we instantiate an object, they are going to be unique to that specific object, like name and age. And we had to use this self keyword to make sure that it was dynamic.
Okay.
However, there's another thing called the class object attribute. And it might look like this. Let's say we had the player character and they had to, let's say, be a paying member. In order to play this game, you have to have played, or you have to have gotten a membership. So let's have a membership equals true attribute.
Okay.
Now, unlike this one, you see that it's on the same line as our methods. And this is called a class object.
Oh, yeah. I do remember.
And a class object attribute, unlike these regular class attributes, is different because, well, it's not dynamic, it's static. So if I click run here, and we want to make sure that we print something, so let's print player 2, and I click run. Well, I get the player, that's great. But if I do dot membership, and I click run, look at that, I get that equal to true. If I do player 1 here as well, and I click run, I get true again. So all the players have membership set to true, but this is not dynamic. It's a class object attribute, which means it's an actual attribute on this class. And this is something we use when there's no change. This is going to be true and exist for all objects. So you can't really modify it. It's just all the objects that we instantiate will have access to it. So this doesn't change across instances. And we can use this down here as well, or anywhere in this class blueprint, as a matter of fact. For example, let's say we wanted to check if membership exists. So we're checking if membership is true, which, I mean, it always is, so this is a little bit redundant. But in here, I can say only if membership is true, then I'm going to assign name and age. But in order for us to access membership, I'll have to do self.membership, because remember, self refers to this player character, so that if I run this, everything still works.
Okay, so I access it as any other attribute.
This still works. Or I can refer to this by the actual player character. So player character.membership. So if I click run here, this also works because it's a class object.
It's a class object attribute.
If I were to, perhaps in the run, let's change this to shout. And in shout, it's going to want to run. Let's remove this line. It's going to print an F string that says, my name is, and give it a name. Do you think this will work? Let's give it a try. Let's say shout, and make sure we run that method, and then click shout again. If I click run, I get an error. Name is not defined on line 11. If I go to line 11 here, name is not defined. Why is that? Well, because we haven't used self. So let's do self.
Ah, okay. I get it.
Run.
Yeah, that makes sense.
There you go. My name is Tom. My name is Cindy. Okay, awesome. And I'm able to use self because I pass it into here as the first parameter. And all methods receive the first parameter as self so that we can use them. But could I just do player character.name? If I click run, I get an error. Player character has no attribute name. Now, why is that? Because name is not a class object attribute. It's not actually a property or an attribute of player character. No, it's defined in our constructor function, our init function. So that's a bit of a gotcha here, and something that you'll have to get used to. A class object attribute is something that doesn't change across different instances, versus an attribute or a class attribute is something that is dynamic and specific to each class object. The way we access them is different, where we can actually access membership like this, but in order for us to access a name or age anywhere inside of our class, we have to use the self.name, which is why anytime we create a method in a class, even if I create a new one over here, and let's say this new one is going to be run, well, once again, I have to use self as a parameter, and then anything else that I want to add in here as the second parameter, so that when I click, let's say, run, I pass in the hello argument.
The hello argument.
I know this is a lot, but hopefully you're starting to follow the rules of classes. Once you remember these rules, then it becomes easier and easier. But we'll
Okay, don't go away, because we're going to try that one out. Okay, so here, well, I'm done with that one. Let's go here. New file. This will be called, how does he call this? Attributes and methods. Okay, class attributes. Class attributes.py. Okay, let's just ask for some help over here. Well, okay, the name and class. Okay, I think I can do it from the scrap. So the first thing I have to do here is define. Okay, I need to define what this file is going to be. So this is going to be class member something like that. Let's use a bank account class to make an example out of it. Okay. So how does this works? I'm going to create a class which is going to be called bank. Oh wait, no, it needs to be like this. Bank account. Okay. I don't need to define anything else here. No. Is this the right syntax? Yeah, that's the right syntax. Okay. And here I'm going to create an attribute for the entire class. What can that be? We may say the interest rate, or yeah, interest rate is going to be, it's not going to be a constant, so because it may change. Let's say the interest rate is going to be 12%. Okay. And let's say that the conversion oh, I know. Let's say dollar to Mexican peso. Dollar to Mexican peso rate, maybe. Multiplier. Something like that. So basically this is how many Mexican pesos do I need to get a dollar. We can get that from the internet, of course. It's sitting down on 20. That's something. There we go. So these are class level attributes, which means that every other object of this class is going to share these values. So what's the next thing I need to do? The methods, obviously. Here is the init. Whoa, it's helping me a lot. Oh, look at this. This is new. Ah, let me guess. This is what I'm supposed to be returning, huh? Okay. Because if I don't do this, what happens? It returns whatever I return on the function, isn't it? Okay. Let's say, okay, self dot balance. It's going to be equals to balance, but I don't have a balance parameter here. So I'm going to create one. Okay, there we go. So whenever I create a bank account, I'm going to assign a balance. Before that, I would like to create a bank account number or ID. Bank. Very descriptive. So self dot bank. Wait, I can just copy and paste this. It's going to be equals to the bank account number. And that's it. So I do have a couple of class level attributes that every other bank account is going to share. They all share the same values for the same attributes here. But every single instance of the bank account class is going to have different values for bank account number and balance. Let's show this. For example, here, let's say account 1 is going to be equals to bank account, and I'm going to need a bank account number, which can be 1, 2, 3, comma, and the balance. Okay, let's say 100. Okay, that's account 1. Account 2 maybe 456 and $200 or 200 Mexican pesos, let's say. I don't know, let's add that's okay, I guess. or 1,000. Let's say 1,000, because Mexican pesos are really nothing. I mean, we are very devalued, so it's not going to be too much money anyway. Let's say that that the currency is Mexican pesos for this account, and we are going to be using one of the attributes to convert. So, for example, if I print, and let's say let's print the name of the bank account. Oh, wait, there we go. What? Account. Oh wait, this needs to be account 2. Okay. So let's print account 1 semicolon space. And now I'm going to well, account 1 dot and what's the name? Bank account number. Okay. So this is a public value anyway. So I can do this. And then here I'm going to put how much money does this have. So I can put here. And by the way, I'm forgetting about the F for formatting. There we go. And here again, account 1 dot balance. There we go. And I'm going to copy everything and paste it for bank account 2 and bank account 2. And let's see how this runs. Okay. Let's go into section 6. Class attributes by. Okay. Now let's run the program. Let's see what happens. Do I get a missing class dog string? It's a warning, I guess. Let's get rid of the warning. What else? Empty class dog string. Okay, it cannot be empty. Anything else? No, not really. Okay. Let's try to run this then. Class attributes.py. There we go. So now I am able to print the bank account number and the balance for both. So something I may like to do here. Well, since the balance is basically a public attribute, so anybody can do anything here. But I may like to create a simple method to get. Well, I will say this is going to be Mexican pesos, right? Mexican peso. Wait, it needs to be here. And I may like to print out the same amount in dollars, basically. That's what I create in this attribute over here. So maybe I can do a simple method called convert to dollars. Maybe the name is not really that great, but who cares? Let's try again. Let's say returns the balance as US dollars. There we go. Something happened here. Oh wait, I need to return. That's the part that he didn't explain. Let's define it as float, right? What else is happening here? Float returns the balance of dollars. Method has no argument. Oh, okay. Do you need arguments for this? Yes, self. That's your argument, isn't it? Okay. Now I only need to return. Oh. I need to return my balance self dot balance, because that belongs to every single object. Every single object does have its own balance. Multiply by this, the dollar to Mexican peso multiplier. Maybe this is not such a good name. And I wonder if I can just put it like here, like this. No, why not? It's not defined. I guess I need to put the name of the class. So I guess it needs to be fully qualified. There we go. Now that is fully qualified, I can save it. And it's working now. Now I need to use this somewhere. So basically I'm going to copy the last message. And let's try with bank account 1, probably. And I'm going to call you are going to be USDs. Okay. But instead of getting the balance, I may like to use the method. Wait, what's the name of the method again? Convert to dollars. Maybe not convert, maybe get as dollars. That sounds better. That makes more sense to me, in my opinion. I'm really bad naming things and people and animals, by the way. So don't be surprised. I'm not rude, I just don't really care that much. I'm sorry. What was the issue here? Invalid syntax, why? Format, account. Wait, is the name wrong? Why is wrong here? F string, invalid syntax, unknown line on my pilot. Did I did something wrong here? Maybe I need to close something. Okay, let's see. Okay, this is closing here. Account 1, number, then I open again. No, it seems to be fine. It's fine, I don't know why. Okay, looks like it's fixed. What else? Okay, I'm going to get, let's try to run it again. There we go. So I'm getting account balance from 1 to 3 on USDs. And I'm getting also the same thing for the same account. So well, maybe I can just save some space here and cut this up. Wait, what did I cut? Okay, cut this up, paste it here. And maybe fix this a little bit because it's going to be confusing. Like this, maybe. MXN first, then USD later. And that's it. Let's do that one for account 2. Account 2. Account 2. And account 2. Let's save it, run it. And now we have account 1 is 1 to 3 with 1,000 Mexican pesos, and that's 2,000 for what? 2,000? No, 20,000. Is that it? Maybe I really confused. Math is not my thing for what you can see. Well, I can fix it very easily, like this. There we go. So if I have 1,000 pesos, that's actually $48. So it's, yeah, our coin, our currency is really devaluated. And now inflation is hitting in May 2022 really hard, thanks to our government. So yeah, stupid decisions, play stupid games, win stupid prices, in my opinion. But anyway, I'm ranting. I am ranting a little bit here. Anyway, the program is doing what it's expected to do. I wonder if I can format the number, the floating number, to just show 2 digits after the dot. I think he mentions how to do that, but I'm going to find it way faster here, I believe. Okay, Python, 2 decimal. Thank you. There is a format here. Okay, and this is the way to show the format. Let's try to open this. In Python, to print 2 decimal places, we will use str format with this thing here. Okay. So number. Okay, but what is this though? I wonder if this is for Python 3. I don't think so. 2020. Okay, let's see an example. Format float. Yeah, but I want with the new version. I don't want to round that. Do we have to? Round. Okay, let's round it. Yeah. I guess it's going to be it's going to look pretty awful, but I guess it's okay. Okay. Right here, I'm going to surround this result inside the function. So the first thing is going to be the arithmetic operation first, comma, and then how many decimals do I want to. And now, if I just run this again, I'm getting 2 decimal numbers. I should probably... well, account number is not... I mean, balance is not rounded, but I wonder if it's going to do something here. I don't know. I guess it's okay. It doesn't really bother me enough. But now we have 1,000 Mexican pesos are $48.83, and 2,000 Mexican pesos are $97.66. So yeah, when you start seeing a lot of zeros to the yeah, you are pretty much doomed. Big numbers for economy. But anyway, what else can I practice over here? I guess I'm done here. Let's see. What else did you do? Okay. Attributes and methods. I guess you can use class level class object methods maybe. So I'm saying maybe I just want to well, I haven't seen security like is this attribute private, is this attribute protected, is this attribute public. For what I gather, every attribute, including the class level attributes, are going to be public at this time. But I guess I'm going to learn just that. Oh, look at this in it. Okay, let's see the next one.
I want to add a quick note about this constructor function. Remember, this gets called every time we instantiate an object. And this is how we create custom objects, right? But an interesting thing that you can do here, because you have control over how the instantiation happens, you can do different safeguards. For example, let's remove this for now because we don't need it. Or actually, let's change this to, let's do age. We want to check if the user is over 18. Then we're going to run this. Otherwise, well, the program's going to error out because we only let people age 18 and over to play the game because, let's say it's rated R. So we can do different things in the constructor to make sure that we are instantiating the object the proper way. We can also give default parameters, like name can be anonymous if we want to do, if they don't provide a name. And then age will be, let's say, 0 if they don't provide an age. So that here, let's say I forget to instantiate player 1 and player 2. If I click run, I get an error. Player object has no attribute name. And this is on line 11. Now,
line 11.
Do we not have self.name? Well, because on line 17, we're trying to call shout. But unfortunately, we never instantiated this because when we don't provide anything, it's going to be 0. So we're never going to instantiate with these properties. Okay, so let's just
Okay,
give
okay,
it
okay, wait.
Tom, and then age is going to be 10.
Again.
Create custom objects, right? But an interesting thing that you can do here, because you have control over how the instantiation happens, you can do different safeguards. For example, let's remove this for now because we don't need it. Or actually, let's change this to, let's do age. We want to check if the user is over 18.
Okay.
Then we're going to run this. Otherwise, well, the program's going to error out because we only let people age 18 and over to play the game because, let's say it's rated R. So we can do different things in the constructor to make sure that we are instantiating the object the proper way.
Yeah, but
We can
you
also
don't
give
have an
default
age
parameters.
already.
Like name can be anonymous if we want
Okay,
if they
yeah.
don't provide a name.
Okay.
And then age will be, let's say, 0 if they don't provide a name.
Okay, still
So
don't
that here,
provide
let's say I
age.
forget to instantiate player 1 and player 2. If I click run, I get
Okay,
a player
an
object
error.
has no attribute name. And this is on line 11. Now, why do we not have self.name? Well, because on line 17, we're trying to call shout, but unfortunately, we never instantiated this because when we don't provide anything, the age is going to be 0. So we're never going to instantiate with these properties.
Okay.
Okay, so let's just give it Tom, and then age is going to be 10. And let's just remove player 2 for now. If I do player 1, dot shout, and I click run, once again, I get an error because, well, Tom is only 10 years old. We're not going to create this error.
Didn't
Now, we're going to talk about
instantiate
errors, and
things.
maybe instead of just having this error out, we can send a message saying, hey, player is not old enough. But for now, I hope you see the power that comes with this idea of constructor and the instantiation of an object, where we're able to add these different controls and safeguards to perhaps make sure that we receive the right data type in order to create the object, or maybe the age is over 18, in order to make sure that when we actually instantiate this player 1 object, we're doing it the right way. So this init gives you a lot of control.
Okay. Okay, here comes an exercise. What do I have to do? Let's practice building some objects on your own and using classes. You can find the exercise and solution files attached to this lesson. Okay, let's see the exercise. Fun times, I guess. I love exercise because the brain needs to work on unknown things, unknown issues or problems to keep growing, I guess. Okay, show files, I guess. Main.py. And let's copy all this. Let's go here. I guess it's a good time to... Oh, wait. Control N. I want to paste everything here before anything else happens. Because I'm going to copy the relative path for this. And add another commit here. Thank you. I don't need you anymore. I don't need you anymore. And there we go. Okay, so let's save this. Given the below class. Let's say exercise 1. Or let's say exercise section 6, 1. Okay. Let's just save it like that. What else? Missing class dog string. Well, I guess down here. That's why you're. There's one here. What else? Module description. There we go. What else? Line too long. Okay, I guess doesn't matter. Given the below class, cat, species mammal, init, self name age. Okay. 1. Instantiate the cat object with 3 cats. What? Oh, okay, I guess I need to create 3 different cats. Cat 1 is going to be equal to the cat class. And I need a name. Okay. Let's call you Andres. And your age is going to be 17th. Cat 2. You're going to be a cat. And your name is going to be Misifu. Something like that. And you are going to be 1. And cat 3, you are going to be another cat. And I'm going to call you Michi. And you're going to have 3 years old. Okay. Instantiate the cat object with 3 cats. Okay. What else do you want? Create a function that finds the oldest cat. Oh. Okay. Well, this function may belong at the class level, although he didn't teach me how to do that. So I suspect that maybe I am stepping one step ahead here, but let's try to do that. Let's try to create a class level. Well, it's actually the same as this attribute here. Okay, create a function that finds the oldest cat. Okay. Let's create here another def get. Oh wait, it's not actually like that. It's like this. How do you name Python method naming conventions? Single lowercase. Okay, best naming conventions for Python. I just want methods. Okay, variables and functions. Why can't you just give me the answer, bro? Okay. Okay, thank you. Use the function naming rule, lowercase with words separated by underscores. Is that for methods? Okay, for non-public. There we go. No. Okay, so get oldest and maybe, oh wait, there we go. And you are going to return with, I think this is return something, telling that the function is going to return something. And I'm going to return a cat. Is that right? Is this how it's done? No, maybe this? I swear I think I... No. Where did I use that? No, it's like this. Oh, wait. Yeah, I'm misusing the semicolon here. There we go. Maybe like this. Okay. And get the oldest cat. Get the oldest cat. So maybe I can... How do I address everyone here? With 3 cats. Name and age. Get the oldest cat. So from down here, I'm not going to be able to do that unless I create a list here. Yeah, I can do that. I can let's just let's go down here and define this function outside the class. Actually, I think that's what he's expecting me to do. And now, okay, here is where I'm going to create the function. But I actually need to write this function up here, somewhere around here, because it needs to be defined before I'm calling it. And let's find the oldest cat. What I'm going to require here is a list of cats, or maybe a list of arguments that can be cats, basically. So either way is going to work. So let's call args, for example. Okay, my arguments are going to be cats. I wonder if I can define that, but anyway. And okay, So how do I find the oldest cats? Well, actually, it's going to be way easier if I just ask for a list, isn't it? A list of cats. And then I just use the, I'm going to assume that's a list. And list of cats dot, the maximum. How do I get the maximum from a list of cats? Let's see. Let's print this out. I need to return the cat that has the maximum age, I guess. So I can do this. I'm going to return from the list of cats, which the index is, like, how do I get the maximum cat member? Oh, I know. Let's try with a for in loop for cat in list of cats. There we go. Now inside this loop, I may like to ask, you know what? Let's create a local variable outside the loop called the oldest cat. Okay, let's call you the oldest cat just to say something. Oh wait, yeah, why not? Oldest cat, and you are going to be equal to a cat without initialization. And that's it. It's just initializing something here. Okay, so the idea is I'm going to loop through the list of cats, and I'm going to assign this list of cats inside. I'm creating an auxiliary variable here to store the oldest cat, which is going to be initialized with no name and 0 age. And there we go. That's going to help me out. The next thing I'm going to do here is, okay, now inside the loop, I'm going to get one cat from the list of cats, and I'm going to compare this particular cat against the oldest cat that I just created. So I'm going to do this. I'm going to assign the current cat. Let's say like oldest cat is going to be equals to the current cat. Okay. If the oldest cat dot age is minus, okay. I wonder if I should do a lesser than equals here. Okay, I'm going to assign cat to, it's going to be the new oldest cat, as long as the oldest cat age is lesser than cat.age. Cat.age. Why is not? It doesn't know that I have an attribute called age. That's why. I wonder if I can specify that this is supposed to be a cat type. No, damn it. Okay, cannot specify the parameter type. Never mind. Okay, let's just hope that this works anyway. And that's it, I guess. It's not going to work. Why? It's expecting an else. No, it's going to be, that's going to be an issue. I'm going to refactor this as a regular if. Okay. If oldest cat age, okay, if oldest cat age is lesser than the current cat age, then do something. Then oldest cat is going to be equals the current cat. Okay? And it's going to do that for all the members of the list of cats. When you are done, you came out of the loop, you just return the oldest cat. And that's it, I guess. What's going on here? Missing function or method doctrine. Oh my god, again. I guess I can put it here. Okay. What happened? Is that the spacing correct? No, look at that. Okay, saving. Oldest cat, a for loop, an if statement. Oh wait, this is wrong. This is not outside the... I actually... Okay, so this is okay. I guess I need to put this one here too, on the same level. Okay, oldest cat, the for loop, the if statement. Okay, and the return statement. There we go. Now it's indented correctly. Okay, let's see if this works. It's going to return the oldest cat because it's going to compare. But now I'm going to need to call the function here. It's going to get get oldest cat. Get oldest. I guess I'm going to call it cat. Get oldest cat. So let's print the get oldest cat, and I need to pass it a list. Let's create a local variable here, list of cats, and you're going to be equal to the list over here, and you're going to be cat1, cat2, and cat3. I forgot cat1. There we go. So we get this. We are getting a list of cats. We print this out. The output is not going to be something readable though, because I'm getting a cat object. So I may like to, well, it's going to get the oldest cat anyway. Let's try it out. Oh no. Okay, so I'm getting a cat object. That's what I'm getting there. So which means that I might like to refactor this a little bit more. And down here I may like to say, you know what, oldest cat. Yeah, I know I'm using the same variable name, but in this case it makes sense because this is a global variable. And I'm going to refactor this as a variable here. And now I can print something more sensible like the oldest cat name is. And down here is where the magic happens. I can say, you know what, oldest cat dot name and its age. Oh wait, I need to escape that. Are you kidding me, bro? No. Where is the other one? There we go. And its name is, and I'm going to insert here the oldest cat dot name, and that's it. Oh no, wait, age. I wonder if I need to cast this as a string. I hope not. I wonder why I didn't do this before with the other one. Oh, no, never mind. Let's try again. The oldest cat name is Andres, and its name is 70. Why did I put its age? There we go. Let's try with more cats. Why not? Yeah, let's try with more cats. Okay. Let's see. 4, 5, 6, 7. I guess there is a way easier way to do this, but I'm just doing this as an exercise. So let's try Yuri. Let's try Mikala. Let's try Coco. And I don't know. Let's try Kira. Yeah, why not? And let's try different ages. 12, 20, if that's possible. And 4 and 5. Yeah, why not? So here Mikala is going to be the oldest. Cat 3. Did I delete that one? 3, 4, 5, 6, 7. Cat 3. Cat 4. Cat 5. Cat 6. Cat 7. There we go. So now I do have more cats, and Mikala this one is supposed to be the oldest. And let's see if it's actually working. And there we go. The oldest cat name is Mikala, and its age is 20. Looks like it's working properly. What else? Print out the oldest cat is X years old. X will be the oldest cat age by using the function to... oh, I already did that one, didn't I? Okay. Michi. Well, I guess since this is a global function, I can remove it from here and create it down here. And it's going to be used later on. So it's okay. Get the oldest cat first call is here in line 43. It doesn't matter. And this, and I already did the second one, so I'm going to do all the calls down here. Everything is fine. I just refactor a little bit, that's it. It's doing the same thing. The oldest cat name is Mikala and its age is 20. It's the same thing, I guess, in my opinion. Let's see. Let's watch the answer. Oh, well, not watch, but to read the answer. Well, REPL is taking its sweet time to start. Okay, let's see what you do. You didn't do anything. Okay, what? The oldest cat is 5 years old. Okay. Okay, class cat, instantiate 3 cats. Garfield, why didn't come out with that one? Let's make this a little bigger. What else do we have here? Find the oldest cat, return. Oh, well, he actually did it way easier than me. He's returning the... yeah, he's returning the maximum from the argument. So args counts as args count as a collection. Yeah. Yeah, the oldest cat. Yeah, I'm going to copy this one for myself. Yeah, the oldest cat. Okay. Orcs. and return the maximum for arcs. Get oldest cat. What's going on here? Redefining name. Let's scout from outer scope. Yeah. List of cats. Oh yeah, because I don't have it there. Doesn't matter. Yeah, I need to delete that one. There we go. Oh wait, it's returning the argument that is I hope it's a cat. If not, this is going to be an issue. But anyway. It should work the same. And it's not. Why it's not? List object has no attribute name. Oh, okay, yeah, I get it. Yeah, it's going to return an oldest cat, a list of cats. Well, it's not really a list of cats anymore. I don't need this anymore. So I can just use these arguments now. They are going to be arguments. And it's going to look pretty bad, but who cares? There we go. So let's zoom out a little bit. There we go. So that's what's going on. This is what is going on. And let's try to run this. Again, not supporting between instances of cat and cat. Ooh, what is not supported? Type error. Greater than. Do I have something else? Between instances of cat and cat. Why is not? Because arcs dot age. Maybe it's that one? No. The max, but how do you know what cat there is? Okay, let's go back to the solution. Okay, you're returning the max from arcs. How do you call it? Get oldest cat. Oh, because he's sending just the age. That's the issue. That's why it's so simple. Yeah, no. I may like to say that I like my solution the best. So let's roll back. Let's roll back for a lot. Okay, what's this? Redefining name oldest cat from outer scope. Why? Okay, can I run this? Okay, it's working properly. What do you mean by this? Oldest cat, redefining name, oldest cat from outer scope. It doesn't really. They share the same name, but this is just locally. Would you like me to rename this? Verbo oldest cat, redefining name, oldest cat from outer scope. Well, if you want, I can just rename this to oldest. What? Why is renaming everything? You're outside the scope, bro. Oldest cat. Let's just rename this as oldest and call it a day. There we go. What do we have here? Line too long. Okay. Are you happy now? Is that it? Yeah, it works the same. I like my solution better because I'm using actual type validation. But I understand that he's trying to keep it simple for the sake of simplicity. And my overthinking brain is doing some work here, but anyway. Let's move on. Oh wait, before that, let's create a commit, shall we? There we go. Okay, class method, add class method and add the static method. Oh, this is great. Let's see. A static method. That sounds like Java. Static methods are methods that exist without needing me to create an object from that class. And class methods, what are those then? Or maybe I'm wrong. I should be wrong. Let's see why.
Welcome back. We learned that we were able to create an actual attribute for the class. But what about a method? Is there a way to do something like here, what we do with attributes, but for methods? Well, there is. And we use a decorator, which is a topic that we'll cover later on, and you'll understand how these work underneath the hood in a bit. But for now, the syntax that we're going to use is the @ sign, and then we call a class method, like this. And now, with this decorator, we can now write a function. For example, let's create a function, and we'll call it adding things. That will take num1 and num2. And in here, make sure we add the define for the function. And in here, we'll just return num1 plus num2. Okay, so what does this class method do? Let me minimize this just so we can see a little bit better. Now in here, let's see if player 1 has access to adding things. So let's just say adding things 2 and 3. If I click run, it takes 2 position arguments, but 3 were given. That's on line 17. So when we call this, we gave it 2 parameters, but then it says that we actually got 3. And that is because adding things, the first parameter, just like we have here, is the CLS. And CLS stands for class. So this player character, that's the class that we're referring to. So similar to what we've seen before, but the standard is to use CLS. Now if I run this, you'll see that we get 5.
Why?
Okay, but looking at this, it looks like it's pretty much the same as the above, except instead of using self, we use CLS. But how is this a class method? Well, it's because we can actually use this without even instantiating a class. Let me show you. Let's say that we don't instantiate player 1. And now I just simply call in here player character dot adding things. If I click run, look at that, I get 5. It's a method on the actual class. It's a class method.
Yeah.
So you can do some interesting things. And by the way, class methods aren't used as often. So if you're thinking, why do we even need this?
No, we need
let's say
them.
95% of your classes aren't going to use something like a class method, but there are cases where this might be useful. For example, we can use the CLS to actually instantiate an object in here. So for example, I can say that CLS, which is the class, which is the player character, and I'm going to instantiate it, remember, just like we did here with the brackets, with num1 plus num2 as the second parameter, and we'll give it name Teddy. If I hit run here, look at that, I've instantiated an object, Teddy, with the age of
CLS. So the name of the current class.
Take this.
That's perfect.
Make this equal to player 3. And if I do player 3 right here, dot age, and I click run, I get 5. So I have a whole new player here that was created by using this class method. So I was able to create, just like I created a class object attribute, a class method using this @ sign. There's also one other way of doing something like this, which is the static method. And the static method works the exact same way as here, except you do not have access to the CLS or the class. So you can't do something like we did above. Instead, we just perform some sort of method, like adding things to like this. So the only difference between the two is the idea that we don't have access in our parameters to this CLS. So we would use something like static method where we don't care anything about the class state. A class state is something like these. We don't care about the attributes, really. We use something like a class method when we do care about these attributes and maybe we want to modify them or change them. Now, these class method and static method is something that you won't see very often, but I wanted to show to you just because you might encounter it through your Python career. Hopefully this wasn't too confusing. In the next video, I want to review what we've just learned up until now. Welcome back.
Okay, before moving on, I would like to make a short experiment here. Because, wait, and did he mention what a static method is?
Object attribute, a class method, using this @ sign. There's also one other way of doing something like this, which is the static method. And the static method works the exact same way as here, except you do not have access to the CLS or the class.
Oh, I get it.
So you can't do something like we did above. Instead, we just perform some sort of method, like adding things to like this.
Oh, okay, so I get it. So static methods are just class assigned methods, and class methods can actually access its own class in order to code with it. So let's make an experiment then. Oh wait. Class methods.py. Okay. Let's create a class called math. Why not? And you are going to be add. You're going to add two numbers, num1, num2, and you're going to return num1 plus num2, and that's it. That's all you're gonna do. But I need well, I need this thing here. So decorator. There we go. I need a decorator now. So you are going to be a static method. There we go. I forgot about the def. There we go. What's going on? Missing function or method dog string. Okay, so I guess I need to add a dog string down here. Okay, and that's it. That's my static method. So I'm not able to do creating anything. Basically, I just return the add static method. What happens if I try to do something similar with a class method? Let's say def that I want to get the difference between two numbers. Number 1, number 2, but you are going to return a math object. Yeah, that's what you are going to do. So what do I do here? Well, I could say, you know what? Let's return a math object. I don't have an init though. A math object, and the value is going to be, well, I don't have an init yet, so maybe I should do that first. Def init, thank you. And you are going to be here like as a self. Oh wait, I need the list of parameters first. Self value, self.value going to be equals to the value parameter. There we go. And you are going to return none. Yeah, it's okay. Okay. So the difference method, I guess, is going to find the difference between two, or I don't know. Maybe it's a really bad name. Let's say make math object. Maybe that's a better name. And let's just pass a number. And I'm going to basically return this, but the number is going to be the input parameter. And I'm going to return a math. Why is like that? Math, undefined variable math. Why is undefined? The type is over here. Oh wait, maybe you need this? No, I don't need to say. I need to say CLS. That's what I need to return. Can I do this? There we go. Why CLS? Not doing it. CLS. Yeah. It's a function. Oh wait, I'm missing CLS parameter. That's why it doesn't exist. Okay. And I guess I can actually ask him to return math. There we go. What's this? Any missing function or method docstring? Okay, I guess. And this is not allowed. Why? Math any. Unidentify variable math. Maybe CLS? No. Math. This is going to be an object, so I guess it cannot be. I wonder why it's not just like this. Okay. So I am creating a new constructor or something like that, I guess. Let's create math1. You're going to be equals to the math class. And I just need to pass a value, 3. And that's it. I created an object. What can I do with this? Well, without that, I can just, before this, I can just print out the sum of two values. How? Math.add. And I can say 0.03, comma 0.02. And that should do something. I wonder if that actually works. Item 3, class methods. Okay, it's working as intended. That's fine. It's working as intended. Now, this is the example for the class method. Oh no, I mean, is the class method? No, it's the static method. And now we are going to create one object, make math object. Well, instead of doing this, because this is going to call the constructor, instead of doing this, I can do this. Call math dot make math object with the same value, and I can print the value. Format and basically there we go, and I can say math1 dot value. Okay, the new math object value is 3. So I created a new math object using another method other than the init method. Okay, I guess I'm satisfied with this. Let's move on.
So the only difference between the two is the idea that we don't have access in our parameters to this CLS. So we would use something like static method, where we don't care anything about the class state. A class state is something like these. We don't care about the attributes, really. We use something like
don't
class
access
method when we do care about these attributes, and maybe we want to modify them or change them.
Okay.
Now, these class method and static method is...
Now, that's important, and I didn't took that into consideration. So, static methods are methods linked to the class, but they don't have access to attributes on the class. And a class method does. A class method is going to allow yourself to have access to the CLS keyword and all the attributes linked to the actual class. Okay.
Something that you won't see very often, but I want to show it to you just because you might encounter it through your Python career. Hopefully this wasn't too confusing. In the next video, I want to review what we just learned up until now.
Reviewing what we know so far.
Up until this point, we learned that OOP, or object-oriented programming, is a paradigm, a way for us to think about structuring our code. We went from procedural to writing functions to now using things like object-oriented programming. Now, what we see is what we call a classical OOP. That is, we use classes to incorporate object-oriented programming paradigms. We learned that we can create a class in Python with a class keyword using this naming convention, which is camel case with capital letter, which tells other programmers that this is a class that needs to get instantiated. We learned about class object attributes. We learned about how we can instantiate an object and how we have this init function that runs on every instantiation to customize our objects. We learned about how to add methods to our class so that each object that we create and instantiate has access to these methods. We also learned that there's things like class method and static methods, which are methods that can be called on the class without actually instantiating it into an object. And all of this was that so we can create our own data type that models the real world. Now, there's still lots more to learn in object-oriented programming. But if you follow these guidelines and look at this overall structure, that's pretty much it. That's how classes work in Python. And we actually have gained a really powerful tool now to really make our code better. Now, the idea of object-oriented programming requires some practice, and it's really hard to grasp when you're just starting out. We're going to try and do some exercises and learn a few more things about object-oriented programming so that we can really grasp this concept and use it in our everyday programs. I'll see you in the next one. Bye-bye.
Developer Fundamentals 5.
Welcome back to another developer fundamental. What is it? It's to test your assumptions. What do I mean by this? Well, anytime you learn something new, maybe something I'm teaching you or something other instructor or book or resource is teaching you, you want to test your understanding and your assumptions. Because you don't want to have any magic black box that things are happening that you don't understand. You want to know how things are working so you can explain it to people. For example, remember how I said that self is referring to this player character class? How can we test this assumption with code? Well, if I had just learned what self is, what I would do is to say to myself, well, I want to see self. I want to know what it is. You know what? I'm going to return here self and actually see what's going to get me, right? It's code. I can return self if I want to. Well, let's do that. Let's create this player character. Yes, I'm 100 years old. And then here we'll do player.run. Let's do a print here and click run. All right. So
returning the
is the
object.
player character that I created, which is player1, which is located here. Okay. So although this is a simple example, what I'm doing as I'm learning is to test my assumption. Is that what I expected? Before I even run this code, I like to think in my head, what do you think is going to happen? And if there's a mismatch and I get something returned that I don't understand, well, then maybe I look into it. For example, this __ main. I still don't really know what this is. Why is this here? I mean, it has to be there for a reason, right? And that's something that we're actually going to talk about later on in the course when we talk about modules. So hang in there. But the way that learning happens in an accelerated fashion is when you don't just take my word for it. Because if you do that, you don't fully grasp the concept. The idea is to test and test yourself as well in your understanding. And say, if my assumption is that self is referring to the object that we create, how can we test it? And this is a great skill that a great programmer has. So hopefully, in future lessons, when I'm teaching you something, you test those assumptions. You test your learning through methods like this. I'll see you in the next one. Bye-bye.
Okay.
Welcome back. What I haven't told you is that when learning about
Encapsulation.
object-oriented programming, again, and not just in Python, but in any programming language that supports OOP paradigm, is this idea of 4 pillars of OOP. The 4 things that object-oriented programming does really, really well. And as a matter of fact, we've actually learned the first one. And that is the idea of encapsulation. What is encapsulation? Encapsulation is the binding of data and functions that manipulate that data. And we encapsulate into one big object so that we keep everything in this box that users or code or other machines can interact with. And this data and functions are what we call attributes and methods, right? We're able to encapsulate the functionality of a player character by having name and age data or attributes, and also have functions that can act upon this name and age. So for example, I can have a method in here that says shout or speak. And the speak method can now use the name and age. I can say, my name is self.name, and I am self.age years old. So that if I do player1.speak, and I run this, my name is Andre, and I'm 100 years old. I'm encapsulating the functionality. If I didn't have this class, I would have, well, some variables and then 2 functions.
Yeah,
But
and
by
I
using
need
encapsulation,
to...
I've packaged this up into a blueprint
Yeah,
that I can create
a
multiple
blueprint.
objects so that when other people see my code, they know, hey, this is an entire object that I can interact with. I can use in certain ways that player character
And all the
interacts.
code
And we've also seen this in our
regarding that
on
class
right?
is there.
When I create a string like this, because of encapsulation, I have all this functionality available to
Yeah,
me. All these methods that I
capitalize,
can access.
peaceful.
So
Oh,
if I
nice.
do, let's say, capitalize, it will capitalize all my strings. I have all this functionality encapsulated for me to use. Now, why do we want to package data and functions into attributes and methods? Well, because this gives us extra power, right? If, for example, this player character doesn't have any actions, any methods, and just had attributes,
Yeah, those
well, in that
attributes.
case, this is kind of like a dictionary, right? It's kind of useless. If I print player1 here, and I click run,
It's
I have
going to
this
give me
player.
that. Yeah,
I can
no, I
access
can-
name like this, and I
Yeah,
can also access age.
yeah, that's not different from
But I
a
can't really do
dictionary,
anything to
really.
I could have the same dictionary here, let's say player2, that is going to equal a dictionary that has name of Andre and then age of 100. And the only real difference between the two is the way I access this information. Instead of the dot notation, I use the bracket
Yeah,
notation
it
to
doesn't
access
make
keys.
sense.
So that when I click run, I have to make sure that I do 2 here for player 2. If I click run, again, it's the same thing. Sure, I can do it this way, but it's kind of useless. Why not just create a dictionary if all I want is data? But using this way, I'm combining things, packaging things up into those instances, into those boxes that can be useful. And also things that have meaning, right? Because our world is full of data and actions, right? Even a tree For example, if we had a tree class in our real world, the tree would have maybe whether it was an evergreen or a perennial. It'll have whether it has leaves or it doesn't, how tall it is. It'll have all that information, but also actions, right? I can cut down a tree, the tree can grow, the tree can extend its roots. So this way, we're able to mimic what happens in the real world with our code. So that is encapsulation, and we've seen it. But let's talk about our second pillar in the next video.
Okay, abstraction. I'm going to stop here because I've been running for 2 hours already. I want to take a break, get something to eat, and stand up and walk and have a walk. I want to listen to something, a podcast, something. Encapsulation, abstraction, private versus public variables. This is the important one. Inheritance, this is going to be a big one, yeah. Polymorphism, yeah, overwriting methods, you know. And that's it. The super keyword, just like in Java, object introspection, I don't know what that is. Thunder method, I don't know what that is. Okay, I believe that we are halfway through section 6. It's great. I'm going to take a break. I'm going to look into Twitter and see what's there. I don't know. It's going crazy right now with the whole how do you call him, the Elon Musk buyout for Twitter. So I'm going to be here a little bit. Maybe if you want to DM me, you can find me at Jorge Escobar. Here it is. You can barely see it. There we go. That's my wife. She died sadly. You can find me at Jorge Escobar, and I'm going to be happy to share my thoughts with you. Who knows? Okay. Well, thank you very much for listening, if you indeed are, and